headphones and not see the answers, or you can see the answers. You have chosen headphones, and you are choosing. But I'm going to do the physics now.
Yeah. I'll be working
on the maths with headphones?
Yeah.
Okay. Could you close the back door, please, Yusuf? It's a bit noisy out there. That was a
You know what happened yesterday?
What happened
They
yesterday?
asked me about this paper.
Who asked you?
Connor.
Yeah?
Yeah.
Did you explain it? The origin of it?
Yeah, I told him you ordered me to print it.
Did I? Yes.
He said he told you. I was like, yes. They didn't believe that you told me. They thought I printed it by myself.
Yeah. Why would they believe such a thing? Outrageous. Okay.
Oh, no.
Where's Fu Wang? Was she?
Mom, Australia Dublin. Oh, that's her.
Oh, it's on this mode. Better switch it so you don't see all the emails I have about Faisal to Connell. Email number 62. Faisal is giving me trouble again today. Please discipline him. Ridiculous.
You finished the paper, Andrew? You started the paper, Andrew? You finished part A, Andrew? You start part B, Andrew.
What?
And then I rage quit.
Part A.
A1 physics. Who has an answer? You have an answer? Don't be shy. What's your answer?
I do have a question. Do we take a formula book for the math?
Yes.
Which one? Is it the one in the movie?
Yeah.
What's
your answer?
What you said turns out to be true.
What?
They add more formulas in the physics formula book.
Yes, it is surprising your teacher was right. What answer did you get, Andrew? Don't be shy.
10 Newton.
And the directions?
In the direction.
Okay. Lee, did you do 10 newtons?
Yeah.
And what direction?
Too many directions.
So many directions. Nice. Okay. Faisal, what answer?
It's a 10. The direction, because they don't give you any direction, just tell you it's perpendicular. So,
no?
Like towards your direction.
Yeah, okay. Can you give me...
north-south?
Open the door.
Omar, do you mind opening the door?
Either
Yeah.
north-south. Northeast, northwest,
Yusuf
southeast,
comes from a
southwest.
very cold country. He's not used to the heat of 21. Yes, okay. I feel like I should do the first one. Right. Lee is absolutely right in that the direction is not clear because they never said the 6 and the 8 are east or north. So it doesn't actually matter. Just choose one and you'll get the marks anyways. So from Pythagoras this is 10 newtons as you said.
Yeah, this would be northeast.
Yeah, so the direction would be tan inverse 8/6. Please, thank you, Andrew.
Have an angle with
Yeah. Yeah.
53 degrees.
Yeah, so it's east 53 degrees 0.1 or something, isn't it? North. Did you not write down an angle?
No, I didn't do the part A. I just went through it. Okay, let's continue.
Alright. A2. 0 point. What did you get? That's a bit different. We better do this one then. Right. you have a mass of 0.434 kilograms, and it's moving horizontally to 13.3, and it's cocked, so it comes to rest then here. What is the impulse? So the impulse is mv minus mu. Wow, come in, why are you late?
Oh,
That one?
one catch.
Why didn't my haircut get that reaction? Right, what answer is this, please? Which exam did you do for one? Physics or maths?
Chemistry.
You did the maths? Which exam did you do for one? Oh,
Too late now.
No.
No? Yeah, no.
Too late now.
The reason I started the physics was because more people had the physics done. Now with their arrival, more people have the
Get
maths
out!
done.
You ruined everything.
But technically they're late.
Okay, wait.
That's true.
What's the answer to this?
Multiply those two numbers.
Like this?
Yeah, 0.4.
Oh, this one is 12.8.
No.
It can't be 12.8.
You got minus 5.77.
Yes. Oh, this one is 5.7. Leave man.
Lee,
shut up.
I saw the difference.
Blah 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 blah. Right, well look.
Let's okay, do part B. Leave the A part.
No, I started the physics, so I'll continue with the physics, so I'll do the maths as well. You know what might be actually better? If you take pictures of each of these pages and send them to me, so that way you can still be looking at the exam. So could you just like snap that?
Share it.
You don't mind?
Yeah.
Ask me.
Anyways, I write down the question.
Okay. Part 2.
This one is 12.
Okay. What's the force? So the force is ma. That's one way to do it. Or the other way to do it, force is the change in momentum divided by the change in the time. So the momentum is 5.77, wasn't it? And the time is 0.452. So this answer, Lee, is... Okay. A3. So far okay, Andrew? A uniform plank of wood. Oh, Suan and Juan. If you don't... Hey, what exam did you do yesterday and why are you late?
You didn't ask them why they're late.
Because they wanted to... The math of the physics. Wong and Suan, if you don't want to see the answers for the physics, you can put headphones on like Yusuf. Or if you want, you can just watch it. Your choice. Alright, A3. A uniform plank of wood, AB, of mass 20.5 and length 2.35 is placed at a pivot located 1.31 away.
What did you draw on this question?
Yes, I was.
You draw, you're like, oh, this is 1.3, this is...
Oh, this was an exam I copied from one of the students who sat it.
Oh.
This isn't my copy, because I don't get a copy of it, so I didn't realize that it was drawn on. 1 point...
Sorry?
Yes?
I did.
Very good, zoom out. Good?
Is it?
Yes, it is. 1.31 meters. And then, a child of mass 18.6 sits 0.823 from end A. 0.823, and the mass here is 18.6 G. Determine the position of second child from the other end would have to sit. And this child has a mass of 25.3 G. And what's the mass of the plank? It's 20.5, and that would be somewhere like here, wouldn't it? And the distance is half of 2.35, so that distance there is 2.35 over 2. Yes, what's that, Andrew? 1.175 meters. Okay, so it looks like this is turning force. Where will we take the turning point? From the left or from the pivot or from the center? I think from the pivot.
Yeah.
Because otherwise we'd have to consider the reaction force at the pivot, which we don't want to do. Okay, so this one here, clockwise or anti-clockwise? Anti.
Clock.
This is clock. You understand that?
You drew the A, I thought that was the arrow. I was like, what? Okay, never mind.
Okay. Right, so the first one, it's 18.6 G, and the distance, no.
From the pivot.
What on earth was the distance for the 18.6? The 0.823, which was this distance here. So from the pivot, that would be 1.175 minus 0.823 plus 20.5 G times 1.175 minus 1. Oh no, the pivot's not 1.175. I'm sorry, the pivot is 1.31. I need to fix that. And then this one here. Yeah, so Andrew, if you could type that in, please. 1.31 minus 1.175.
11.8.
Including the G? And 16 Newton meters. Then the clockwise one, the distance here is 25.3 G times the distance to the pivot. Now the pivot is not in the middle. So how big is this distance here? Well, you know what? I'll just call the x the distance from here to here. So I'll just have x here. So I have 116 equals 25.3 gx. So x is 116 over 25.3 g. And this will be the distance from the pivot. 0.47 meters from the pivot. Okay, that seems a believable number. Did you get that? You didn't do it. Lee! What answer did you get for number 3? You did it wrong.
No, it's not wrong.
No,
It's
that's
just
not
a different way.
But did you consider the reaction force when you picked the center? Then you did it wrong. 8-4. What's wrong, Andrew? You look confused. More so than usual. No?
No.
Okay. A ball of mass 0.476 is at a string and it's spun around on a frictionless icy surface in a horizontal circle of radius 4 in. The string also moves in a the string can support a tension of okay, fine. So what you have here is circular motion. You know the radius is 0.312 meters. The mass is 0.476 kilograms. And the force is 14.5 newtons. And we want the omega. So F equals m omega squared, or the omega is square root F over m, or that is square root 14.5 over 0.476 times the radius, which is 0.312. That's it. Oh, it's only 2 marks. Lee, did you get this? Are you sure? Can I trust you? I trust you. 5. A wire of length 2.46 and diameter 0.32 is attached to bridge support on a load of... Okay, so this is your Young's modulus question.
They
Yeah.
give Young's modulus, but they don't give stress and strain. But it's just, you can extract it from the Young's modulus.
The extension is 4.27 millimeters. The force is 6.52 G, and the diameter is 0.32 millimeters. And the question is, what's the strain? So, strain.
Yeah, the extension over the length. That's it.
So, that's it.
4.27 times 10 power negative 6.
That's actually okay.
Negative 6 or negative 3?
3 over 2.46. So what's that?
1.74 times 10 to the minus 3.
Cool. And lastly, Young's modulus. So Young's modulus is stress over strain.
Stephen, I want to ask, there are no units for this strain?
Correct, it's unit free.
But like in all the other marking schemes, there's always like meters.
The extension is meters and the length is meters, but the strain is...
In all the marking schemes, it's
Give me
always like
one example of an exam where they give units for strain, and I will buy you a copy.
Yeah?
I'll get you a copy.
After this.
Stress over strain, which is force over area over 1.74 10 to the minus 3, which is 6.52 G over pi or squared. Okay. Did you get this, Faisal? Are you sure? On to 6.
Could you just go back to the previous one? Just take a picture.
Steady. You got it?
That's fine.
Okay, 6. A cell of 3.25 volts. Oh, this one's a bit different. They give you the internal resistance. So this is 3.25 volts, and this is 0.133 ohms. And it's connected across to a 5 ohm resistor. What is the current? This looks like what type of problem? He's Russian.
Kirchhoff.
He's a little bit crazy. We all love him.
Kirchhoff.
Yes. Which rule? Loop rule. So you have 3.25 minus 5i minus 0.133i equals 0. So I equals 3.25 over 5.133, which equals... Did you get this, Andrew?
Yes. 0.633 ohms.
0.633 amps, no less. Dun dun, there goes a mark. A second resistor is connected in parallel. Ah, this one's a little bit interesting. When the second resistor is attached, the current increases what?
You lost the coffee.
Show me.
Question, marking scheme A2AI.
The marking scheme is wrong.
It is wrong, actually. No, it is wrong.
But the problem is, all the past papers that I've done, the strain always has the unit meters, and I never understood why, because
But
they
that's
get cancelled.
wrong.
Frappuccino?
Yeah, Frappuccino?
No, I have my hot chocolate.
I'll take it.
Yeah, Andrew, you're right to feel troubled by this because it is wrong. You're correct. The units cancel. The strain is unit free.
Those are the people that are determining our future.
Yeah. Well, it won't be the first or last time there's a mistake in the marking scheme. That's why you've got a very diligent physics teacher correcting your exam. And nobody objected to that. Sweet. Right.
What's this 2.34?
Yeah, what happens in part 2 is a second resistor is connected in parallel, causing the current to change. How big was that resistor? It's the second part of the same question.
So how did you get 2.34?
It's given.
Oh, okay, that's not the answer.
No, I'm only starting it. So, let's call this resistor actually, let's call it X. And we'll call the total resistance here R. So, in the new situation, 3.25 minus RI minus 0.133I equals 0. But we know what I is. So it's 3.25 minus 4 times 2.34 minus 0.133 times 2.34 equals 0. So the new total resistance will be 3.25 plus 0.133 times 2.34 over 2.34. Total resistance, please, Andrew. Are you sure? 1.26 ohms. Now this is not the resistance they want. This is the new total resistance. So we know 1 over 1.26 will equal 1 over 5 plus 1 over x. Yeah? So x equals 1 over 1.26 minus 1 over 5 inverse. 1.68. Now, that's actually hard, but at the same time it's 4 marks. Okay.
Oh, yes. I did say,
Are you asking me something?
What does it say?
No, I
don't
did
know.
the question very similar.
Okay, did you get the right answer? Good for you. You're in the same club as Lee, who got this right then. What is that sound outside? Right, can I scroll down? What's wrong? Go on. For this? Well, maybe Lee's wrong. Lee, are you wrong?
No, he's not. This is, I just got the...
Maybe you're wrong.
Do you have the inverse?
Yeah, sorry, my handwriting's bad, I know. Okay, can I go on to 7 now? Right, so far, what do you think of this physics exam?
It's not bad.
I know. So,
How did they fail? I was thinking, how did they fail?
2 of them failed.
Yeah,
Yeah, you're thinking like, yes, no definitions.
there is one.
Yeah, just one, wasn't it? In B, what was the definition of?
Gravitational.
This is
Then 2.
Specific heat capacity. Yes, I remember, because I got the worst definition I ever got. Specific heat capacity of a material is the temperature it's at specifically. That is a true story.
that was this year.
I'm like,
Name.
what?
Name.
No name. Give me a name for that.
Yeah,
That's
yeah.
embarrassing.
Yeah.
What exam did you do yesterday? Speaking.
Leave
I'm
him,
defending him.
leave him alone. He had no context. He just came into the classroom. But anyways, yes, every year it amazes me how badly people do, because every year I think, that was an okay exam. Oh well, maybe I should just stop having hope. Okay, 7 now. 7. A 5 ohm capacitor is charged to Sorry, I said ohm, I don't know why. A 5 microfarad capacitor is charged to 40 volts, and then it's discharged through a resistor of 3.5 mega ohms. Determine the time taken for it to fall to 25 volts. Well, this is just your V equals V0 E minus T over tau. So you have 25 equals 40 E minus T, and the time constant is RC, which is 3.5 times 10 to the 6 times 5 times 10 to the minus 6, and that's nice because they'll cancel. Yeah, so what's that now? 17.5, yeah. So 25 over 40 equals E minus T over 17.5. So what's that now? That's 5/8, which is 0.625. Well, now I have to do log. Yeah? So log here cancel. So the T will be minus 17.5 log 0.625. And the answer is... What is it? Yeah, it's okay. 3 marks. 8 now. A, B. 8 microcoulombs, 4 microcoulombs. Distance between them, 0.06 meters. And then a third charge is in the middle of 5 micro. What is the magnitude of the resultant force on charge C? What is the direction? Okay, well, I think I'll answer the second part first because that's easy. Which way will the charge move? These are all positives now. So which way will it move?
To the right.
Towards B, yeah. Okay, now let's do part 1. What is the magnitude? So the force will be, there's 2 forces acting on this. One force pushing it to the right from A, and one pushing it to the left from B. So the force to the right will be K, Q1, Q2 over R. Well, you know what? I'll use different letters. I'll say QC, QB over R squared minus K, QC, QA R squared. So that will be K over 0. Now, I'll put in the numbers. 8.99 times 10 to the 9 over 0.06 squared. And then I could take, you see what I'm doing, Andrew and everyone else actually, this is in common to both. So I'm taking it out. Oh, sorry, thank you, Lee. That should be a 3. Thank you. So QB minus QA. And what was QB? 8. And QA? My handwriting is terrible. What was it? It was 4. So the difference is 8 minus 4. So 4. Okay, so this is the answer then. What this is. Charge of C I did, didn't I? Oh, sorry. Oh, I'm glad Lee's awake. I'm clearly not. I forgot my charge of C. Charge of C is 5. Okay, now we're good. Please type it in, please. This is 8. Ah. 200 newtons? That big? That seems really big.
5 times 4.
Can you? Yeah, 199.7. His story checks out.
What's the K?
8.99 times 10 to the 9 constant in the Coulomb laws formula.
These different formula. The
What?
F is equal to charge 1, charge 2
Yeah.
over 4 pi E0.
Yeah, that's the same formula. You should get the same number.
Unless
Epsilon 0 is on your calculator.
Did you use epsilon 0?
Yeah, the E0, yeah.
Okay. 9 now. What you do wrong?
I divided the distance because it was half,
Yeah.
and then I wrote it down as 0.03.
Yeah.
But then while I was doing it, I divided it again, thinking
Ah.
that's the distance.
Well, you won't make that mistake again, we hope. A column of air containing a vertical glass tube is partly filled with water and open at one end.
I wanted to ask on this one.
Okay, what we're doing now is made to vibrate at a frequency of 256 Hertz. And this happens when the length of the column is 0.31 meters. And the velocity of air is 340 meters per second. And what is the end correction? Fundamental frequency means it vibrates like this.
Doesn't the water affect it?
The purpose of the water is just to change the length of the tube, that's all.
The length of the tube?
Yeah, you fill it up with water so that you can get the tube to whatever length you want. It's like reducing the length of the tube.
The last tube.
So it acts as
Yes.
so wherever the water stops,
Yeah,
that's where the voice
Yeah.
stops. Okay.
that was it?
Yeah.
What?
Okay.
No, what?
I understood something else.
Alright. Now, this question. Yes. Let's just ignore this for the moment. Just for the moment. And using this, let's calculate the speed of sound. So the formula is V equals lambda F. Now in this case, because this is a quarter of the wave, that would be 4L F. So that would be 4 times 0.31 times 256. What's that, please?
$317.4.
317.4 meters per second. Now you can clearly see that that's not right. The true speed of sound is 340. And as I said with this experiment, a common reason for the error is that it's not exactly a quarter of the wave that fits in here. It's kind of a little bit unclear at the top here for many reasons. For example, the tuning fork isn't exactly producing the sound wave right at the entrance here, and for other reasons too. So there's a little bit of an error. Can I just have the calculator there just to double check something before I tell you something which I'm not 100% sure if I have it right. Yeah. So what will happen is the V the V will be 4L plus an error times F. And they're saying show that this error is 0.022. So the true value here should be 340. So that's a 3-1 there. So if I solve this, oh, I did not get it. Let me try that again. What the heck is wrong with this calculator? Oh my goodness. Right, so when you solve this, you get error equals 0.022. So you didn't have to do this bit at the start. I was just doing to show you what they mean by an error. That if you estimate the V using the lambda and the F, you don't get exactly the right answer. This is actually all you need to do in the exam. But I think this question is a little bit tricky. Students don't like this one. It's a bit hard to understand, I think. The next part is water is, yes?
For the end correction, is like, you know you need to complete the error.
Yeah, end correction means the error.
It's always before or...
Yeah, they usually use this word in the exam, yeah. Water in the lower part of the tube is allowed to drain out so that the length of the air column is gradually increased. This continues until the air once again vibrates. Determine the new length. Okay, so they just want to know the length of the next vibration. So the first vibration happened when it was like this. When will the next one happen? When it's like this. Ugh. I drew that badly. Like this, I think. And this is a quarter of the wave, and this is now a half of the wave. No, that's wrong. The next one will happen when it's like... Yeah.
What are you doing?
I'm having trouble right now.
The first one was right.
This is right. I was right the first time.
Yeah.
I need to... No, I start at the bottom would be easier. I need to have a node here.
It was this and this the above accident.
Yeah, antinode at the top.
Top of both.
Top antinode, bottom node.
It has to be like this.
Has to be, yeah.
So the middle is no.
Middle is node. Yes, that's what I'm trying to draw. A quarter of the wave, and then 3/4 of the wave.
Yeah.
Yeah. So the length would be equal to 3 times 0.31. This would be the next length for the vibration. Yeah. Yeah. They increase the length until the next vibration happens. Well, actually,
it can happen before as well. Like, won't there be a vibration at 2/4 lambda?
no.
Why not? It would still make a...
It wouldn't be an antinode at the top, though.
It only makes a vibration if it's an antinode at the top?
A noticeable vibration. What's your question, Florence?
Then that's the answer to her question. It has to be an antinode at the top. So the next
In
one
the
would be
I don't know if you remember this, but in the lesson on standing waves, I had a picture of all the different.
harmonic.
It's not saying anything.
It's an English question. Water is released, and this gradually increases the length. Determine the length when the next frequency vibration happens. This continues until the air once again vibrates. That's the key sentence. No, you don't like it. Oh, don't ask him, he wasn't listening. You should ask him, he was listening. That's wrong. You don't see where the words are in this for this, yeah? Can you see where it says, this continues until the air once again vibrates? So what you have is, you have a wave, and then you increase until you have the wave again. And you must have an antinode at the top, and a node at the bottom. What?
He's preparing his cocaine to sniff it with the car.
Perfect.
He's giving up.
Alright, let's continue before we get into
How's
trouble.
it going then?
Eta. A light of wavelength dash and dash and dash. Okay. Please, have mercy on me. Right, so the wavelength is 389 nanometers, and the velocity of the electron is 7.85 times 10 to the 5, and you have the formula that HF equals work function plus KE, and we want the work function, so that's HF minus KE, which will be HC over lambda minus a half mv squared, which will be H, which is on the calculator, C, which is on the calculator, lambda, which is 389 nano, minus a half m, which is on the calculator, and then the 7.85 times 10 to the 5 squared. And what is this answer? In electron volts.
3.19 times 10 to the 10.
Easy.
That's a lot of electron volts. Did you get this? Electron volts. Yes. Fixed?
Yeah.
What?
I wrote down everything the same way, but the calculation is just...
That's life. Okay, threshold frequency is H over work function.
Yes.
No,
No,
work
work function.
Work function over H, which would be 1.44 E over H.
3.48
Right, that's section A. Now on to section B. What questions did you do in section B, Lee?
Oh,
Good for you. Andrew?
I did...
Yeah.
I did 1,
Yep.
2,
Yep.
and 3.
Good. If you
I'm attempting 5.
good. Good. 4 is ugly. Right, let's start with 1. Lee, here's your chance now. Define gravitational field strength. Go on, don't be shy.
The field of magnetic field that is generated by the Earth.
0. Andrew, did you get this one? No, you didn't do this one. You did this one? Yeah.
G is equal to big GM over R squared, where G is gravity.
Babe, guys, define, you have to speak. What are
No,
we-
you can use the formula as long as you define each term in the formula,
Where G is your gravity.
etc., etc., yeah.
Big G is the gravity.
In words, G, why you, in words, G is the force, well, no, let me be even more precise.
What I wrote was the amount of gravitational field an object experiences when the object is inside that field.
1 mark. The gravitational force experienced, no.
Exerted.
Oh, much better, yes. The gravitational force exerted
By the object.
on a mass.
Orbiting.
No, it doesn't have to be orbiting, you see. Gravitational force exerted on a mass per kilogram while in a gravitational field. Could even draw it as well.
So I only missed a mark for per kilogram.
It's force per kilogram. Yep. Okay, part 2.
What is nice.
Assuming the Earth is a sphere of radius that and acceleration is that, show that the mass is that.
You just use
The formula, the G
G
equals.
equals GM over R squared.
Yep. So what are we looking for?
They give you everything.
The
They want
mass,
you to
is
prove
it?
The mass, that's it.
The GR squared over
Big G.
G. 9.81 times 6.37 times 10 to the 6 squared over 6.67 times 10 to the minus 11. What do we get here? 5.96 times 10 to 24. Nice question. Warm you up. And then the next one is nice as well. Density is mass over volume.
Yeah.
So 5.96 times 10 to the 24 over 4 over 3 pi 4 cubed. And what do we get here?
3.5.1 times 10 power 10.
No. 10 power 10. Do you realize what density you're saying the Earth is?
5.14?
Thank you. 5.
5.14. Wait, let me calculate because.
No.
Yeah, 551.
10 to the 10. You know that's wrong, Faisal.
But
No, don't give me buts. Don't give me.
look at this. Right?
No. Don't give me any buts. You know that's a ridiculous answer, and you are no right to say and complain about this. 10 to the 10.
24
10 to the 10.
over 9. So not a 9.
What not? No, it's not 9. It's an 18.
Yes.
Yes. Do
How
not
did I
turn my
get this?
classroom into a house of ridiculousness.
How did I...
Don't know how you got this. Right, continue.
Okay, yes, this one. I used this big board and I wrote so many things down. Wow. But it wasn't anything from the formula book. So I googled some things to solve this question.
Did you now?
I'll show you.
No, don't.
No.
The International Space Station orbits the Earth at a height of 412,000. Now, that says above the surface.
Yes.
They tried to trick you a little bit.
Didn't work.
Didn't work good. So we have to add
6.37.
6.37.
0, 0, 0, 0, 0, 0.
Now hold on, don't confuse me. 6.37. 1, 2, 3. I need another 0. No, that's not right.
6.37. 0, 0, 0.
I have too many zeros, do I? Is that?
4 zeros, 4 zeros.
Ah, screw it. 6.37 times 10 to the 3. Right.
Another 3.
No, the
So
rest.
6.37 times 10 power 3 kilometers. So another 3.
Oh, that's what you mean. Oh, but this one is in kilometers?
Yeah.
Oh, but I already converted it into meters.
Okay.
So then another 10 to the 3. Yeah. That. I feel like they made a mistake because how could a space station be 412 kilometers only above the surface?
Only 412 kilometers above the surface.
Ireland is like 200 kilometers long.
412 is
Twice Ireland.
that's that's more than any commercial airplane can fly.
Let's check what Wiki says.
Times 3 kilometers. And this is 412 kilometers. That was your question? Your doubt?
No. What's the problem here? 412 plus 6370.
Hang on.
Times 10 to the 3, no?
Oh, it's not 400. Yeah, see,
412.
412 kilometers.
Exactly, so...
I'm just
Yeah.
saying that seems awfully small to me for a space station.
412 kilometers. This is 6,300, 6.37 times 10 to the power 3 kilometers. So this is 637, 1, 2, this. And then kilometers, 1, 2, 3. So this is 4 zeros and this is only 3 zeros.
No!
No.
I...
It's
Guys.
not 412 times 10 to the 3.
Guys!
I'm speaking in
I
meters.
know. I apologize. 412 kilometers is the distance above the surface. It just seems like
Reachable?
reachable.
You jump?
Well, I mean, like Ireland is like 200 kilometers.
Yeah, walk the distance of Ireland. How long will it take you?
It wouldn't take me long to drive.
4 hours? No, more than 4 hours. From
6
north
hours.
to south.
6 hours maybe.
Yeah.
So I can drive to the space station in 12 hours. I just
Against
need,
gravity.
I just need to drive vertically. I'll just activate my vertical drive mode. Right, okay. Alright. And the time taken. So they want the orbit. Okay.
Yeah, they want the time.
So this sounds like Kepler's second.
Who?
Kepler's second
Who?
law, yeah.
Who?
Yeah,
Kepler. So what's Kepler's second law here? It says T squared equals 4 pi squared over G
See,
M
this is
or
not
Q.
given.
I know it's not. I said many, many times this is not in the formula book and it's
Really?
something you need to...
Nice. This is one of the times where I regret sleeping in class. But I used this and then I got the answer.
This is what you did?
Yeah, Lee and I got the same answer.
So, what was I looking
And the
for?
answer.
So I was looking for...
What are you laughing?
I was looking for the T. Yes? So this is square root 4 times 3.1415 squared times 412,000 plus 6.37 times 10 to the 6 cubed over 6.67 times 10 to the minus 11 times 5.96 times 10 to the 24, and they want this time in minutes, so then divide your answer by 60.
Yes, it gives 92.7 minutes.
Correct.
But
But what?
this satellite will spin around the Earth in 92.7
Correct,
minutes.
that's what it does.
That's really, really fast.
I know it is. So they see the sunrise many, many times a day.
Yeah, but like that's extremely fast.
Yes? What's your point?
Like I was sitting there, I was like, what? This is really fast. This is wrong.
Well-
But then I did it with another method, and I got the same answer.
Yes, and what does this tell you? The maths was right.
But
Steve, I wanted to ask.
Yeah.
Let's say I did this,
Yeah?
but my calculations are wrong. My
I know it's a recurrent theme to your attempt at the exam. You did this, you wrote the formula down correctly, you put the numbers in,
No.
but then going to this step here, it went all wrong, is it? Yes?
Let's just say that happened.
Okay, yeah?
Do I get a mark for writing the formula?
Yes, you get marks,
and working, you
Yeah.
just miss a mark for the final answer.
maybe 2 marks. But don't do this. What? I mean, what? Don't do this.
It
What's
doesn't.
wrong?
I do everything exactly
No,
properly
no.
correctly. It just
Do them separately.
that's the only difference. I do them separately.
Don't do them separately.
I don't do it separately. I try to bash it all in the calculator in one go, which uses errors.
I think it causes more errors.
And which of the two of us now has a higher track record? Waiting for your response. Okay.
That's a quick question.
Yes.
This is second, Kepler's second.
Yes.
Kepler's first. No, really. Is it a formula?
It's not a formula.
Third.
It is a formula.
Is it given?
No.
What is it?
I'm not telling you. You can
Hey.
look it up.
Lee, what's the third? Kepler's third formula.
That's not it. That's not what I gave you in class.
R2 over R1.
It's close, yes.
V1 over V2 is R1 over R2 or radius?
Yes.
Right, C. What is the period of rotation? 24 hours.
Yes,
Did you get this, Lee? Andrew, did you get this?
You get this?
Sorry. Andrew, sorry, you look quite similar to Lee. Did you get this?
No.
Maybe next page.
I put in the...
Oh,
That's fine, yeah. Part 2, what is the angular velocity, which is the omega,
Yeah.
which is 2 pi over t, which is 2 pi over 24 times 3,600. What did you get, Lee? 3. What is the radius? What formula will we use? We use Kepler's again?
Yeah.
Yeah.
And the
T squared, no, yes. 4 pi squared or cubed over gm. So the or will equal cube root gmt squared over 4 pi squared. And what did you get here?
Why is it so blurry?
What's-
It's not just me.
Oh, did you do it? You made it worse.
No.
Yes, it made it worse. No, bad. Yeah. There.
But then when I sat down, it got worse.
Sit down slowly. Fine. Fine. Right, what was the answer? And finally, what's the V? The V equals omega or, which will equal 7 point, well, we have the omega and the or. 3. Why not say just 3.07 km per second?
Yeah.
Okay. 2.
Zoom out, please.
Who did 2? Good. Good question?
Yes. exponential graph, not the LM graph.
Oh yeah, they wanted the graph exponentially.
Yeah, it
So
doesn't give the proton number.
Okay, let's have a look at it. First one is to plot the graph.
Why do you want proton number?
We'll do it now, don't worry, we'll do it now. Okay. Time in days. And then activity. Make it sound more French. Le Becquerel, thank you, yes. Right, so we have 0.
We didn't have to do this.
What? Now I can just copy it down.
Now
What?
this takes like 3 extra seconds.
What takes 3 extra seconds?
Making the graph.
I don't know what you're saying. I'm so just going to ignore
Making,
you.
why are you making this on this application?
Because I'm making it nice and beautiful for you.
Oh.
What?
No.
No graph?
No, I have a graph here. This is disgusting.
Possibly.
Yeah.
Right, now this is key for getting the marks. The graph is
Format. So you
activity against
get
time. And the x is time in days. And the y, activity in kilo equals.
Best thing I worked since I came to Ireland.
Yes, all exciting. I am a hater.
Yeah, I know.
That's okay. I accept who I am.
I hope one day the society accepts you too.
Yes. Now, did you get a nice graph like this, Andrew?
Yeah, actually, the graph is better than
Let's
mine.
see.
It's just a little bit skinny.
Not so bad. Not so bad. So now, unfortunately, because it's not a linear graph, we can't use our usual method for calculating half-life. However, if we remember what half-life means, the time to half the activity, then if we look at this graph and go at 300 and down, we see that the half-life is 10 days. Because it starts at 600
More
roughly.
than 10 days.
I think it's 12.
Yeah, I said 12 as well.
Because
Don't look at the big square, look at where it cuts the 300 line.
329.
I apologize, you're right. 12 would be more right. Thank you. So, for A part 1 we've done it and part 2 is 12 days. Now what's the decay constant? We can use our formula. Decay constant equals log 2 over the half-life. What do you get here? Now actually, if I can take that for a sec. Now, Faisal, listen carefully. You have two choices here. You can actually express this answer in this form, per day, if you want to keep using day, or if you want to use the usual unit, you would have to convert it into seconds. You have a choice. Okay, part 3. No, that was part 3. Part 4. How could the results in the table be used to obtain a straight line graph? In other words, how can you make a graph a straight line?
Make it L. Insert logs. Use logs.
Log the
Introduce
activity.
logs.
Log the activity.
Log the activity.
Yeah.
Really? Insert logs.
And how would you get the decay constant from this graph?
Ask the graph, nice.
How would you get the decay constant from this graph?
Like the gradient.
It's the slope.
Yeah, the gradient.
Yeah. Is it, wait, is,
Run.
Yeah.
Rise upon dawn?
Yeah.
I've never heard of this before.
Okay. Is it minus this? Yeah, it's minus the gradient, isn't it? How to get the decay constant?
From the Ellen graph.
Yeah, it's minus.
Yeah, yeah. So how many marks have I got already? Shocking amount. 4, 5, 6, 7, 8, 9, 10, 11, 12.
I have a question.
Yes. Why do you get 12 marks for doing so little? I couldn't answer that. Next question? Yes.
For the unit, I wrote hertz.
Yeah. Fine.
Yeah.
What is the energy? So, RA223 undergoes alpha. Oh, I see what Lee means about the proton number. So it becomes, yeah. So it becomes RN219 plus an alpha. Yeah?
Yeah.
So the mass on the left is 223.0185 atomic mass units.
What did they give 4 marks for this question?
Again, like I just said, I don't know why you get so many marks. This is why I say I really like this atoms question in the exam. It's like a gift of a question. Yes?
Even suppose they give us like a question similar to this, but they ask us to like finish it, right? So they put like question marks.
Oh, you don't quite have enough here to do that because, like Lee said, you don't know the proton numbers.
Suppose like
Yeah.
we have what we need for the alpha.
Yeah, it's HE42.
So do
Yeah. You can balance it by using that. Can you add the two numbers on the right, please?
What I did was I just wrote this number and minus this minus
Yes,
this.
I know.
So will I not get the full
You will
marks
get
or
the
not?
full marks.
So I don't have to write it like this and write equation and you know what.
No, I'm just doing it because it's so easy. I'm trying to make it look more difficult.
What's wrong?
I calculated this with the.
I know, without the U.
223.011.
011. That's math. So the M is equal to 0.0075 U.
Yeah. Yes.
Yeah?
Yes.
So then the energy, which is what they call the Q,
MC squared.
which will be 0.0075 U, and then C squared. Should be a big enough number.
1.245. I used kg, not so do you use kg?
Yeah.
You convert 0.75 to kg.
Yeah.
Okay, so 1.245 times 10 power negative 29.
That's smaller than I would have thought. Lee, what did you get for this one?
Please read the right one. The right question.
1.25
Yes, I thought that was too small. Faisal,
0. Point.
what is it?
1.12 times 10 to the minus 12.
That sounds more like it.
Wait.
Okay, part 2.
What is C? Yeah, I have the C.
If all the energy released becomes kinetic energy, determine the recoil
That's the
velocity of the radon element. So what happens here is this becomes kinetic energy.
Then I have the last one wrong.
Okay.
I have the
All the energy.
All this energy becomes kinetic energy at the alpha. Yeah. So they want, you have a half mv squared equals 1.12 times 10 to the minus 12.
Whoa,
So
what
V
is
is 2 times 1.12 times 10 to the minus 12 over 4.0015 u square roots. What's that?
Why did I tell you 29? I have it minus 12.
I don't know.
Then I have the last one right. 1.57
Is what?
is V. But 1.57 times 10 power 9.
Is this V here?
The V. The final answer.
Yeah, but I'm not at that stage yet. I'm only getting the velocity of the alpha.
What?
But it's
Oh, okay, then that's what I did. That is the velocity.
velocity of
Recoil velocity.
like
Of the radon? Yes.
this is like over the mass of both of them. Because kinetic energy of this mass are
Oh, nice. I did very wrong things.
Oh, combined kinetic energy.
yeah.
I see. Thank you, Lee.
So they have this one.
No, they don't. This makes it much more difficult. Not impossible, just much more difficult. Alright. This is going to be quite hard for 4 marks. So what's happened here is you have the OR A, and then the OR A decays and becomes OR N and an alpha. And this will move left and this will move right. And we want to know what is the speed here. I'll call this one V1 and this one V2. So this is conservation of momentum. The momentum before is 0. And afterwards will be M1 V1 plus M2 V2.
Oh.
Now what is the M1? That is 219.0095 U V1 plus 4.0015 U V2 equals 0. So cancelling the U is you can get this equation.
Nice.
But unfortunately, what's the problem here?
That's what it means.
Yeah, so we need a second equation, and the second equation comes from the energy. That the kinetic energy here and here came from the energy released previously, the E equals mc squared. So now you have a half m1, I'll write the formula down, a half m1 v1 squared plus a half m2 v2 squared equals 1.12 times 10 to the minus 12. So now you get a half 219.0095 U V1 squared plus a half 4.0015 U V2 squared equals 1.12 times 10 to the minus 12. We should divide everything by U. Can you do that divided by U, please? Oh, and we'll multiply everything by 2. So then afterwards multiply it by 2. So we get 219.0095 V1 squared plus 4.0015 V2 squared equals
1.35 times 10 to the
1 point,
35
yeah,
times 10 to
now I don't think this is the way they want you to do it, because it's quite long and quite hard. So can anyone think of maybe some other way to do this one? I can't really think of it.
I did something, but I think it's wrong. E equals half mv squared, and then you find the V for...
That's what I was doing originally,
for
but
the alpha, yeah.
that's the alpha. Okay, what did you get for the V for the alpha? Maybe you could type this in.
My mistake was I used...
Okay, all I want to know is what did you get for the V for the alpha?
What I did
I'm
was
not interested
wrong.
in talking to you right now. Give me the V for the alpha, then you can talk to me.
Okay. Theta squared. Okay, what are you doing?
Joking?
Okay, die. Good. Times 1.12 exponential minus 12 for 6.6 or 6.7? What's the U?
Shift constant 17.
Shift constant 17. Wow! 1836065.1.48.
1836.
065.14. 51.48.
I don't care about the decimal.
148. 0.48.
But that's wrong.
Yeah.
Because, as Lee said, that's the kinetic energy combined. So it looks like we have to do it this way, but this is one ugly math problem.
You know what? We know the method. We can leave it.
Yeah, but I'm going to see if I can find the mark scheme.
You think there is another Stephen that leaks papers?
There's more than one Stephen. Physics mark scheme. Let me just make a phone call. I need to get the password for something. I'm done.
007, what is going on?
Hang on. That biology teacher never answers his phone. Maybe Joan will answer her phone.
You don't know the password to log in the teacher's account?
I usually remove the password from these things, so I never remember it. Because I'm like, so what, my marking scheme gets stolen, I don't care. Hi Joan. I'm just in class looking at the marking scheme. I just can't remember the password. Would you know it off the top of your head? That's what I thought. Capital. So. Will do. Thanks, Joan. Thanks.
Yes. What?
Oh my goodness. Recover web page. Piece of junk. Sorry, Internet Explorer just crashed.
Oh, how unexpected.
Of Internet Explorer? Yeah.
Honestly, Chrome is really nice.
Chrome is okay.
I prefer Chrome over. There is this one thing that I used to use, it's called Citra. Citra. It was awesome. It has a built-in torrent. So it was really nice.
Oh my goodness.
Firefox crashes a lot with me. Starts lagging when I'm watching videos.
Oh my goodness. There we go. Right, I have the mark scheme here. Let's have a look.
Can you, since you already crossed your boundaries, print or give us a copy of the math marking scheme? Because we won't have time to finish the mathematics.
We can do it
paper.
tomorrow.
But, you know, we don't have much time to wait, so we want...
Do it. Not Firefox, Explorer keeps crashing. I try to scroll down on the PDF. Ooh. Right. Let's have a look here at B2. OMG.
What did we miss?
That is how they do it. It is like this. So you have one linear and one quadratic to solve. That's a blank. A big
You
blank
know
and blank.
the name of the examiner? Who did the exam?
Perhaps.
But if we went this far,
Yes, how many marks?
3 at least? No?
2.
The good news is you get 2 out of 4 for going this far. And the remaining 2 answers you get 2 marks for finding V1 and V2. I can't believe it. That's outrageous. 4 marks for all of that. Outrageous.
And then to answer the orbit, you get 2 marks. So it's equal to the time of orbit of Earth. But no, can we get this? Can I
Yeah.
take pictures of the screen while you're not looking?
Perhaps.
And the math as well, please.
Perhaps.
I know we're asking for a lot.
Perhaps. Tomorrow.
Why?
I can print it for you.
But we can print it ourselves.
Look. Tomorrow. Okay.
Math and physics?
Yes.
Deal.
Sorry, deal usually implies like I could do something for you and you do something for me. I don't.
Wait.
What?
I'll
Oh,
wait.
you'll wait until tomorrow. Oh, I see. Okay.
I would have been telling you that long ago.
3 now. What did you think of number 3?
I left it. Because I was like, oh, Newton. No need to
Okay.
waste time.
Question? 3 is good.
Yeah.
Yeah, it looks nice.
Maximum height. UVATS. U is 17.5 sine 15. B is 0. A is minus 9.81. T you don't know. And S
Minus 30.3.
is what you want. I don't need to do this, do
Oh,
I?
not the up one.
So when you work this out, you'll get S equals 30.3 meters. But that's not the final.
No.
Oh, sorry, not 30.3. What am I saying? Sorry. 1.046.
Yeah.
Yeah. But then you need to add 30.3 meters, and you get the answer is 31.3 meters. The next part is the time. So just get the time here. Whatever. S equals UT plus a half A. No, V equals U plus AT would be the easiest one to do.
What is the time?
0.462. Number 3 is the time taken for it to reach the sea. So again, this is UVATS. U equals 17.5 sine 15. B we don't know. A is minus 9.81.
Okay, it's just
T we don't know. And S is...
minus 30.3.
Very good. And using our usual formulas,
5 marks.
we'll get 2.99 seconds. Yeah, it's nice.
5 marks for this?
Just
Yeah.
for this.
That's all we have to do?
Yeah. What formula? S equals, I think. You could have just said S equals, you know, the usual formula, UT plus a half AT squared. It's just a quadratic, and you get, it doesn't make sense. You get 5 marks for solving this quadratic, but you only got 4 marks for solving
don't want
one
us to
linear
lose
and
marks.
one quadratic.
That's the only explanation. They don't want us to lose so many.
It's set up so that passing should be easy, and yet every year I'm always amazed. Right. How do I get the horizontal distance?
We make U cos 17.5.
Yeah, the range it's called is 17.5 cos 15 times 2.99, and that will equal 50.5 meters. What is the V when it hits the ground? So again, that's just getting the V from earlier. What formula could we use? We could just use V equals U plus AT. Do we know the U? Yes. Do we know the A? Yes. Do we now know the T? Yes. So working that out, we get 24.8 meters per second. What's that?
Oh, wait, vertical,
Yeah. And then lastly, what is the kinetic energy when it hits the water?
Half mv squared.
Yes, but what do you use for the V?
I know this trick.
Yeah. Or the way I like to do it is the kinetic energy when it impacts the water is equal to potential and the kinetic when it's launched, because of conservation of energy. So that would equal mgh plus a half m 17.5 squared.
Oh, nice.
Pretty sneaky.
Yeah.
383 joules.
17.5.
The initial speed.
Ah.
If we do it the other way, we'll have to resolve the vector of speed. Yeah, this is nice.
This is the Stephen way of doing it.
The easily way to do it.
That's how I roll.
KE at end equals VE plus KE at beginning.
Number 4 was a ugly question. No, because it's good for you to see it.
The sign.
But I'll do it at the end. I'll do 5 next.
Why? What's wrong with it?
Oh, that prism question. Don't you
It's
remember?
just a really long one. That's
Yeah, I
it.
know. Don't you remember me doing it in homework?
I remember. So I left it.
Right, anyway. Specific heat capacity is the capacity to have heat
This one.
specifically.
Yeah.
Yeah. That one.
What specific heat capacity, Lee?
The energy required to raise a unit temperature per unit mass.
Oh, so close.
1 unit.
Yeah, specific heat capacity is the energy required to raise a unit mass by a unit temperature. To raise 1 kilogram by 1 Celsius.
4 kilogram.
Okay. What?
Why not it raise the temperature?
By 1 Celsius for 1 kilogram. Specific heat capacity is the energy required to raise a unit kilogram, a unit mass, by a unit of temperature.
The energy needed to
Raise the mass.
No,
raise the temperature
of the mass.
The energy needed to change this from 20 degrees to 21 degrees.
It's your grammar, Lee. It's your grammar. You don't say raise the mass. You say raise the temperature of the mass, or raise the mass's temperature, or raise the mass by 1 degree. By. You forgot. Grammar. Right. Part 2. So this year the students did have an experiment question. Describe an experiment to calculate the specific heat capacity of a solid. Okay, so we could imagine an experiment, perhaps. So, let's say, if you want to know the specific heat capacity, what you could do is,
Measure the object mass.
first you need to know the mass, then you need to have some water here. And usually, what way do they do this? I think usually they boil one of them.
How can we measure energy?
I'm thinking, hold on. I'm thinking about what would be the easiest way to do this one. Yeah. What you do is you measure the temperature of this one. I'll call it T1. And then what you do is you have this boiling at 100 Celsius. So they got the flame here. Boiling at 100. And then, once it's at 100, you turn this off and put this in. So you know that this temperature is at 100. And then you give it a mix, and this will cool down, because this will take the energy from this. And they'll both reach a final common temperature, which we'll call T3. And of course, obviously you measure the mass here, and obviously this mass you can know as well. So the metal will gain and this will lose. So the energy gained by the metal will equal the energy lost by the water. So that would be M1C, which is what you want, and then the change in the temperature, which will be T3 minus T1. That should equal, and then lost by the water, that would be M2. The water is 4120, heat capacity of water, and then the water will lose energy, so that would be 100 minus T3. So because you know everything except the C, you can work out the C. The C will be 4120 M2 100 minus T3 over M1 T3 minus T1. So the steps will be 1. Have M2 at 100 Celsius. 2. Put M1 into M2. And of course, at the very start you want to note the T1, which is the temperature of M1, and then you mix and then measure T3. Roughly, you can write it more nicely than that. Let's see what they wrote in the exam here.
What about the error?
Oh yeah, what would be the cause of the error here? Heat loss through the surroundings. So you would want to put some kind of insulator on it, but of course it's impossible to put the insulator on it perfectly, because you'll have to take the lid off to at least put the metal into it. So it's going to be heat loss as the main source of error. In the marking scheme, they said they don't even have formulas or diagrams, they just describe it in a paragraph. The solid is weighed to find its mass and then heated in a boiling water. A calorimeter, which is the name of the container, is weighed. Oh, that's the other thing I forgot. You have to also consider the copper as well. Yeah. In my experiment, the copper has no mass.
Oh, nice copper.
Actually, it's not copper. It has no heat capacity either.
Oh, it's divinium.
It's stevenium, yes. It's massless as well as having no heat capacity. Yeah.
Is it a rainbow color?
Depends on the time of the year.
Oh,
Yeah.
okay.
Yeah.
Mostly green.
Mostly green. Okay, next one. B1. State Boyle's law for an ideal gas. What? Is he being dirty? What's he saying?
Same as the blue when it's sick. Is it not blue?
It is blue, correct. Yeah. I'll print out the marking scheme, you can write it down. It's a long paragraph. Okay, what's Boyle's law?
Did you ask about Boyle's law?
Yeah, what's Boyle's law?
The pressure is inversely
PV
proportional
equals an RT.
Yeah, to the
to
volume
the volume.
at constant temperature. Okay, 2. An ideal gas at temperature 273 Kelvin and volume of 0.765 meters cubed, and pressure 0.632 times 10 to the 5 pascals.
Go on, bro. Go on.
So, this question here, what happens is the pressure then changes. You need to go? Fill it up yet? The pressure increases to 1.01 times 10 to the 5, and they want to know what is the change in the volume. What law do you think you use here? I give you a clue. They just ask you to say it.
PV equals nRT.
Well, you could, but it'd be much easier just to use foils. Because the pressure has increased, so the volume will decrease. So, Andrew, can you just hit in 1.01 divided by 0.632?
Cross multiply and then you... What are you doing?
1.518.
So, the pressure has increased. What?
Awful.
What? The pressure has increased by this much, so the volume will decrease by that amount. So if you could divide that volume by that number, we have the answer.
0.4787.
Okay. Part 3, what is the N? So PV equals nRT, so the N equals PV over RT, which will equal 1.01 times 10 to the 5 times 0.4787 over 8.31 times 273, and you get what did you get here? Yes, 21.3 moles. And I misread the question. They want the number of molecules. So we need to take this and multiply it by Avogadro's number, and we'll get 1.282 times 10 to the 25 molecules. Yeah? Okay, next. C. A flexible container is filled with 0.2 moles of hydrogen. The density of hydrogen is 8.36 times 10 to the minus 2 kilograms per meter cubed. The temperature is minus 21.5 Celsius. The temperature is increased to 15.5 Celsius. What is the new volume of the container if the pressure inside is to remain constant? Right, so what they've done here is they've put some gas into a container and they've increased the temperature, but they want to keep the pressure the same. So
they have to change the volume.
Huh?
They have to change the
volume has to change, yeah. So we could go with PV equals nRT, P1V1 N1T1, and then P2V2 equals N2 or T2. But of course some of these things are the same. For example, the N, the number of moles is the same. What else is the same here?
Oh.
The R is the same. And what else is the same? They said they want to keep the pressure the same. So let me just rewrite this as P1 over N1 or equals T1 over V1, and P2 over N2 or equals T2 over V2. Now why do that? Well,
compare
these are all the same. P, N and R don't change. So that means T1 over V1 equals T2 over V2. And now we can get the answer. The T1 is minus 21.5 plus 273. And the V1 is something we have to work out. The T2 is 15.5. plus 273, and the V2 is what we want. How do we get the V1? Well, they gave us the density. Density is mass over volume. So volume is mass over density.
4.78.
You worked it out already?
Yeah.
What is it?
4.78 times 10 minus 3.
But where'd you get the mass from?
You see, they
and
tell us that we have 0.2 mole of hydrogen, and the atomic mass of hydrogen is 1. So that means the mass is 0.2 grams.
no, 2.4.
0.4?
One hydrogen molecule has 2 atoms.
Oh, I'm sorry, yeah, hydrogen is actually H2, thank you. So, Andrew, 1 mole of hydrogen is 1 gram. So 0.2 moles of H2 is 0.2 grams. Wait. No, you don't need to know about the H2 part. 1 mole of hydrogen is 1.0 grams. So 0.2 of a mole is 0.2 grams.
No, the mass of atom is 1. So
Oh, sorry. No. The mass of 1 hydrogen atom, 1 mole of 1 hydrogen, was 1 gram.
But the
Oh, but it's 0.2 moles of hydrogen gas.
So not H.
So it's 0.2 moles of H2. Yeah, sorry. Thank you, Lee. So it is 0.4 grams. Right. So you know the mass and you know the density, so you can get the volume. Okay. So what did we get here for V2?
0.149 times 10
Okay. That is correctly. Right.
Done with the exam.
No, we said before to do. I said I'll leave it till the end.
Oh.
Okay, B4.
Me. B for me. B there for me.
Are you doing the last question?
Yeah.
What are you going to
10 minutes break.
And then?
I don't know. I'm doing the last question now.
You know, he will troll you and he'll go back home. And he'll get sick tomorrow and he'll send the papers to Connor. Then you just get the marking scheme tomorrow.
Hey,
And it says a joke on you.
yeah. I don't know. It's looking like I may just finish this and we finish.
Can I just ask one question?
For the math? For what? What's
Do
the
you
top-
have the same question?
What's the topic? Huh?
Distribution by specific. No,
Let's do it quickly as a bit of a break from the physics. What is the question?
No, I meant a break from everything.
What's the question?
And now, the limits are log 3 and log 2, log 3, and then integrate 3e to the power of 2x, and the 2 and 8, it's not over 1 plus e to the power of 2x.
Ah, it sounds familiar. I think I had a FISO with this recently.
And then
U equals...
EX.
Yeah, so what does du dx equal?
EX.
Yeah, so what does dx equal? Du over
EX.
yeah, so now this can be rewritten as log 2, log 3, 2u squared, 1 plus u squared, du over u, because ex is u. So I can change dx into du over u. That cancels. and you're left with integrate 2u over 1 plus u squared du. And this is a special type of integration where the top is a derivative of the bottom. This integrates into log 1 plus u squared. If you did not know that, you can see that by using the second substitution, v equals 1 plus u squared. That was a welcome distraction for 30 seconds. The problem is, I make all of this look too easy. And I think this is why people don't study enough, because they feel like, oh, this is an easy exam.
It's very big.
Which one? 10. This is an old exam, isn't it?
Yeah.
It's not on the current syllabus. Not on the syllabus anymore.
No.
I'm keeping these. Nice. What flavour? No, thank you. No, thank you.
I don't take no for an answer. Cheddar and radish.
Delicious.
Just like me.
Are we doing questions now?
No, I know what you mean. Am I typing? Hey, Swan, look what I have.
What is this?
Oh, you don't understand.
What is this?
We both like the same face wipes.
You're not my teacher.
Sit down. I'll print this out for you tomorrow.
Yeah, I want to do that.
Don't have to. Wait, I'm coming too.
Wow. Can I go with the one?
What, do we have a break now?
It wasn't my intention, but people need to go to the bathroom, so we're taking a bathroom break if necessary.
I just have a really small question.
No,
No?
you can't. Well, what topic is this? Maths or physics? Ah, what exam?
B1 for
That's an older one.
14.
Okay. I'm taking questions tomorrow. I have this current exam to finish. Go on! Where are you going? More water? Yeah. Does anyone have any chocolate? No?
I have whipping
Go.
cream. I have whipping cream.
Dude, that's so kinky. Why have you got a can of cream in your bag?
Because we thought it was strawberry milk. And he bought it and he was like, Andrew, here you go. That's what it is. And I opened it and it was whipped cream.
He thought whipping cream was strawberry.
Like,
There's no word in strawberry milk that matches whipping cream. And then,
No, it's strawberry whipping cream.
oh, okay. Well, okay.
I really want to ask you this question.
All right, come up.
This is the limit.
Yeah. No, I'll do it tomorrow because he'll want to see it too.
No, but why, like...
Tomorrow he wants to see it too. Don't
my
you?
problem is, no, just asking which one is it.
Oh, okay.
See, I just want
Yep.
to know, like, and here's the length.
Yeah.
They considered two, like, they multiplied the length. Well, I added them. Why would they multiply the length?
They multiplied by 2?
No, they, like this, multiplied by...
Oh, because the formula has area in it. Yeah, because the formula for
IBAN?
torque is IBAN.
And we do not take sine...
No. No.
There's no sine. And this is the direction. Okay, the direction of the course, that's right or left?
Left.
Yes, I used left. This is field,
This is field.
and this is current,
Yes.
and then this is the force.
Yeah.
So how's the force? Oh, where's the force going?
I don't know. Which way is the field going? The field is going to the right,
Yeah.
and the current is going down into the board.
Are these the current line, the arrows?
And no, I don't think so. It's not clear. They say current up, current down. It's not clear. This is current going into the page, is what they meant, and this is current coming out of the page. So here the current is going in, okay, and the magnetic field is going to the right, so the force is going up. So this will go up here. So it's going to rotate clockwise.
So
It's not a clear picture. It's going to rotate clockwise. No, your hand's upside down. Yeah. No, point that finger in. Point this one into the screen. Yeah, so the current is going in and the field is going right. Oh, sorry, apologies. This is the field. Oh, I'm wrong. This is the field. This is the current. So, yeah, so it's going anti-clockwise then. Yeah. Okay. Does anyone have any chocolate? A little something. I'm starving here. Nothing. My appetite is starting to return. I didn't have anything to eat today because I didn't feel like it. I think I told you this. My breakfast was a Lucasade, yeah. And I know it's called. You do? That'd be awesome. Are you going to starve to death now if I eat one of these?
No, one.
Great. Just one will do. That'll tide me over.
do you like salt and vinegar?
Yes, I do.
And these chocolate biscuits that are green.
No, it's good. This is good. Check now. Yeah, check now. Actually, no, you don't. The exam I gave you yesterday, that has the latest formula book in it. You can check that.
Why don't you write because you have two answers. This one. It's an inequality. You have two answers.
On again?
Oh yeah, so and you don't
have half-life.
You don't write K equals that's wrong. It's any value under the
They have beyond the multiple.
I don't think it does, you see.
Huh?
I don't think so.
They have beyond the multiple.
Oh, it does?
Yeah.
Awesome.
I didn't do it. I didn't put the numbers. Is this one how much do you
Alright.
the control my way is
So you cannot have any answer. They have
I
half-life.
just put in the numbers. The way is
Well, mine is 53%.
They have a radioactive decay half-life. That's it.
That will be the same as what you get. out those other students who are taking a long time.
Why are these exams way too different from the ones of before?
Do you think?
Yes. Well, the
Way
ones of
different.
Yes, I feel like the ones of Model are all semester two stuff. Nothing from semester one. This one has.
Oh, math?
Yeah.
Because
Oh,
math
that's-
is divided into semesters.
Yes, that's because that's true.
Okay.
Recently, they changed it so that the final exam includes everything, whereas in the past it only included semester 2 topics.
That was even 14, 15. Yeah.
Correct, yep.
That's a good thing. I think.
Well, considering that semester 1 has easy topics in it, I think it's good for some students. What happened in the past was a lot of students did well in semester 1 exam, then badly in semester 2 exam. It probably seems like it's easier.
I think. Yeah.
Okay, let's have a look here. A narrow beam of purple light contains 2 colors of wavelength. 6 times 10 to the minus 7 meters. And then the other color we don't know. The same light source is used in 3 separate experiments as described below. Okay, so part A, the narrow beam of purple come on, move. Okay, so this light here is red, this one here is violet, and together they make purple. And the purple is used, and they want to know what is the space in between the lines on the grating if n equals 2 for the red and the theta equals 47. So we can use the formula n lambda equals d sine theta, and we get d equals n lambda over sine theta. So the d is 2 times 6 times 10 to the minus 7 over sine 47, which works out to be 1.64 micrometers. Okay, part 2. The third order violet line is also at the same diffraction angle. Determine the wavelength of the violet. So they tell you n equals 3, theta equals 47, and the d is still the same. What's the lambda? So using the same formula, lambda equals d sine theta over n equals 1.64 times 10 to the minus 6 times sine 47 over 3, and you get 4 times 10 to the minus 7 meters, or in other words 400 nanometers. B. The purple light is then used in Young's double slit experiment. The slit spacing is 0.25 millimeters, and the distance between the 4th red fringe on one side of the center to the 4th red fringe on the other is 24 millimeters. What is the distance? Okay, so we better draw this one since there's a bit going on in it. This is the formula I always mix up. Big D, small d, and is it lambda? And that's S equals, yeah. So here we have our slits. We have our S here. and here we have the D, and the D is 0.25 millimeters, and this we don't know, it's what we want. So we know this, we want this. Do we know this? Yeah, we're looking at red, so we know this. Do we know the S? We do. They tell us that the distance from the fort on the left side to the fort on the right side is 24 millimeters. So that means S is 24 divided by 8 millimeters, because they gave us the distance for 8 slit separations. So the D is S lambda D, which will be 0.25 times 10 to the minus 3 times 6 times 10 to the minus 7 times 24 over 8 times 10 to the minus 3, and that works out to be, I guess, 1.25 meters. Okay, part 2. Huh? Why did I what? Add? No, these are multiplies. Oh, zoom out.
When we finish, they open new apartments in different parts.
Right.
That has a gym.
Determine the spacing for the violet color. So the spacing will be lambda D over D, which would be 400 times 10 to the minus 9 times 1.25. No, sorry. Oh no, that was it, sorry. 400 times 10 to the minus 9 times 1.25 over 0.25 times 10 to the minus 3. And that will equal 2 millimeters. Okay, and lastly,
No, it's fine.
part C. Where did Omar go?
The potion disappeared.
The what now? What?
The potion.
The Persian disappeared.
No, the potion.
Persian.
No, she doesn't. Yeah? She sells seashells.
How was your speaking exam?
I'm prepared to participate.
He probably
He got
did.
his mark. Why do you think he's upset and he's wearing black?
What mark? Did you get your mark? I didn't think so. Ah, speak of Omar. We were wondering where you were. You didn't get your mark.
The potion.
What was the topic?
It's about money and happiness.
Huh?
Money and happiness.
Happiness.
Does one lead to the other?
You need money to be happy.
And you said, sure, why not? Or,
We said, sure, why not? And no.
okay. Good.
I said money is more important than
Happiness?
and he says happiness is more important.
Good. And did you come to a conclusion at the end?
Yes, gold digger.
Yes. She's a gold digger. Oh. She said, given the choice between having a happy marriage or a marriage with lots of money.
Money.
I don't hear any defense.
It's okay to think like that.
But like the poor, if they don't have money, they
can't
aren't
live.
happy. They're not happy because they don't have money.
So they could marry rich people.
Yeah. Well, it means
That's
they have
one
money,
way
they become
they're
equal.
happy.
Yes.
Yeah, so they balance out.
Yes. Do you think rich people would like to marry a homeless person?
She's really hot, yes, they
They
will.
like the rich people like to
She's
marry
really
the
hot.
rich
Huh?
people. The rich people
Doesn't go
like
any other
to
way.
marry the rich people.
That is true, they do. They do.
That's
Persian.
marry
Persian.
so I can marry
They don't give
The poor
passports.
Persian.
They don't give
No, she
passports.
wants to become rich so she can marry rich.
A rich Persian.
If you are rich, you don't marry a poor Persian? No?
There
But
are
if you are poor, you will marry a rich Persian.
but I want to be
If. Imagine.
so I have to
You
go
fail the
out of
IST
it.
and you become poor, you don't want to marry a rich Persian?
But I can't be a poor.
It's impossible. It's impossible for her to be a poor Persian. It's not going to happen.
All it takes is a little snip of cocaine.
That's it. And the descent into the poorhouse begins.
Yeah. I have it here if you want.
They're pointing out how you say person. Yeah. Not Persian. No, you're saying Persian. Person, yes. No.
Person.
No.
Person.
Yes.
So she's
Say it
capable of
again.
saying it.
Yes.
Oh, yes.
The other way, Persian, is a person from Persian. A Persian person.
Yeah, the Persian from Persia.
Iran, yes.
Persian from Persia.
Yes,
Persian
I
from
realized
Persia.
what I was going to say, yeah. A Persian from Persia.
Persian person.
A Persian person from person. From Persia. I think we could make a new tongue twister on this. Okay, last part here, C, the prism. The Persian person sells seashells.
Seashell on the seashell.
Close enough. I think it was by the seashore.
Shell.
Not bad.
Persian person.
Right. Finally, the beam of purple light is incident. Here? More.
No doubt.
And then go up here.
Why did you want him to zoom out?
Finally, the beam of purple light in air is incident on a triangular equilateral prism. So all these angles here are 60. Determine the angle that the red line makes with the normal as it leaves the prism. So there's a normal here, there's a normal here, and it comes in at 55 degrees. So it will leave at a different angle, of course. This is the normal, so it's going to come over to here. And this is 55, and this angle is not 55, it's going to be, we'll just call it X. So you have sine I over sine or equals N2 over N1. And do we know it? Yes.
Yes.
So this gives us the X. What do we get there, please?
1.53 over sine.
Okay, this one is not as hard as the one I gave you as homework. There's less to do here.
Whoa.
What did you get?
Matero.
Great. Perfect.
No, I know the trick. Oh, my trick again.
32.78 degrees, correct. Now, when we look over here, we need to figure out what this angle is. Now, here's the key question is, if we know this angle, can we know this angle?
Of course, yes.
Is that the triangle?
Well, we don't know, is this a right angle triangle?
Yes.
Is it?
No.
Yes, it is. They have to meet eventually.
Yeah, but that doesn't make it a right angle. So let's examine this in more detail. What?
You are making a triangle. You can make it a right angle if you want to.
No, I can't just make it a right angle triangle. That's not how triangles work. 60, 60, 60. Okay, now we'll put this coming in here, and I don't know. It was like this, wasn't it? Now we don't even know that these are on the same level. This one could be up a little bit higher. Right, so that's 60 there. We know this angle. Can we know this angle? This one here is parallel to this. Why? Well, this one here is perpendicular to this. No, it's not parallel to that. It's not. No, you see, you can't just make it whatever you want.
You made a mistake.
Oh no, don't talk. I need to think. Please. That's 60. That's 60. So that's 30. Because this is 90. So this one here is 30. Yes?
How did you get the 60?
Yeah, what's this line?
That's 60. This line is parallel to the horizontal I draw.
So you just made that one.
I just made a horizontal line. If that's 60, that's 60. I can do that. If that's 60, that's 60. Agreed? And if this is a normal, then this is 90. Agreed? If this is 60, then this is 30. If that's 30, then this is 30. And by a similar logic on the other side, I can conclude that this is 30, because it's symmetric. If that's 30 and that's 30, that's 60. So this angle here is 120. So is this angle 120? No, it is 120. I'm sorry, I meant to say in my head, is it 90? No, it is 120. So, if I go back here, this angle here is 180 minus 120 minus 32.78. And then we have this angle. And that is 27.22 degrees. So once again, we're looking at the light when it comes out. So I don't know, we'll call this angle y. So sine y over sine 27.22 equals 1 over 1.513. So then we get y equals 43.8 degrees.
Wow.
What?
The voices.
The voices in your head?
Yes.
Yeah.
I have voices in my head, they counsel me, they
Can I continue? Now that question was a bit tricky. That question was a bit tricky. Not as hard as the one I gave you in homework, but still difficult. Lastly, what? The violet light has a refraction of the... Oh no, wait. No, I did that one. Oh, here it is. Oh, there's still two more parts.
Okay.
I'm a very sick man, and if I kill you, no jury will convict me.
Are you sure it's worth equal?
No.
17.6.
Okay, thanks. 17.6? No, it's not. What? But I'll believe you. Continuing. Right. The violet light has an angle of refraction at the face of 32.32. Determine the refractive index of the prism for violet light. Oh. Right.
So easily.
No, it's so boring.
You're a teacher.
Fine.
You're supposed to be a role model. Not giving up so easily. Getting sick and you skip the day. What is this?
I skipped half the day. Yeah, and I don't think it's a coincidence that I got sick after I saw Andrew. Just saying. He comes in with his magic hexagons, and then the next thing you know, I'm cursed. It's like some kind of pentagram or something. Look into the hexagon, huh? Right, the refraction is, so sine I over sine or equals n2 over n1, and we want n2 here. So, oh wait, no, yeah, what is it? It's just that over that. So what do we get, like 1.53 or something? What do we get there? I do see.
1.5.
Not 1.53?
I believe we have reached a limit today.
2.78.
We're literally on the very last part. After
Write
this.
the answer, write it down.
I will.
Finish.
Is it 1.53? What are you... What?
I don't see the
Yeah.
You got three different answers. Thank you, Fuang. Right, now for the last part is a stinky, sucky, stupid question. They make you do part one again, except for the violet light instead of the purple light. I know, stinky question, and instead of getting 6 marks, this time you only get 3. And not only that, they want to know what's the difference between the two answers. So the difference between the two answers, I'll just write it down here for you, is 1.58 degrees. So this is repeat part 1. So this is I hate when they do this in the exam, because it's a very lazy way of making an extra question. They say, just do the same thing you did but for a different colour and give me the difference in the two angles. Now, it's nice when it's an easy question and they get you to do it twice. It sucks when it's a hard question and they get you to do it twice. Yeah. Right, so what do you think of the physics paper? A's all round? Maybe a couple of A stars?
If it's a God's work.
I think a bit of study might have something to do with it as well. Al is great and all, but he's not going to be able to help you if you don't know anything, you know. Yes.
God will help those who help themselves.
Yes, yes. And a bit of study would help yourself. Okay. Tomorrow we'll do the maths paper. And then, didn't you say you wanted an extra class or something tomorrow?
extra class.
Didn't you say you wanted an extra hour or something? Are you all smiling? And I was like, no.
That was next week.
Oh, that's right. Sorry, next week. Okay. So tomorrow we'll do the maths then. Okay, I think on